Here's a solution to problem 4.11 in Miller. In this problem, we're given a series of circuits and told that each switch has a probability P of being operational, and the switches act independently of one another. So for part A, the circuit is, we have at the first junction a choice between taking the path through S1 or S2, and then the second junction just S3. So to figure out the probability of this circuit being operational, we break up the possibilities into disjoint events. So there's three ways for this circuit to be operational. It'll be operational if all three switches are open, an event with probability p cubed. And to argue the p cubed, we're using the independence. Each switch has probability p of being open independent of the other ones. So that's one option. The second option is that S1 and S3 are open, but S2 is closed. Now, S1 and S3 both have probability P of being open, which is the P squared, and then the 1 minus P is the probability of S2 being closed. And then finally, S1 could be closed, but S2 and S3 could be open, and that similarly has probability P squared times 1 minus P. And again, since these are all disjoint events, we can calculate the probability the circuit is open by just summing the probabilities. Okay. That would be the third axiom of probability. Now, the second circuit in part B, in this one, basically we just have one initial junction which leads to two paths, and then as long as one of those two paths is open, the circuit will be open. So in this example, it's actually easier to use the law of complements and figure out when the circuit is not operational, and it's not operational only if all three switches are off. That's an event of probability 1 minus p cubed, so the law of complements tells us that the probability of this circuit being open is just 1 minus p cubed. Now in part C, we're given a significantly more complicated example. However, note here that if we call the top path O1, the middle O2, and the bottom O3, then the circuit is closed only if all three of those paths are closed. So we're going to calculate the probability of open by calculating the simpler probabilities P of O1 complement, O2 complement, and O3 complement, and by independence we can just multiply those three probabilities together to get the probability that there is no path through the circuit. Right. Now if you look at O1, O1 consists of two parts, but those two parts are identical to this first circuit here, right? And so to calculate the probability of O1, we just need to figure out the probability that that first circuit is open. Okay. And we're going to leave that calculation to the listener to compute. For O2, there is just one way for that path to be open, and that's if both of those segments are open. Okay. And O3, we will also leave that calculation to the listener.